we'll see how we do. All right, so we've got u is 5i plus 4j, so 5i. Plus 4j minus 3k, and we've got v, which is 2j minus k. Okay, so first of all, we just need to find the unit vector for u. Now just remember, unit vector says travel in the same direction as u, so u is like 5 across, 4 up, and then 3 back into the board, right? So it's kind of going in that direction as my arm. But I want to go in the same direction, but only across one step. Okay, a magnitude of 1. So first things first, are you happy I'm going to have to find what the length of u is, and then make sure I go that many times smaller? Okay, so how many steps is u? How could I do that?
Square root of.
Yep.
5 squared.
Yep.
Plus 4 squared plus 3 squared.
Yeah, negative 3 squared or 3 squared is the same thing.
Yep.
Right. Okay, so that's going to be 25 plus 16. That's going to be 41 plus 9. Is that square root 50?
Yeah.
Yeah, or 5 root 2 if you wanted to cancel it down, because square root of 25 is from square root 2. Okay, so that's the magnitude. That's how many steps that u is if I started from an origin and went to the end of u. I don't want to go across all those steps. I only want to go across one of those steps. So all I'm going to do, if I say u hat, remember this is u hat in the sense it's a unit vector now, not an estimator. We're not dealing with statistics anymore, right? This is going to be 5, and I only want to go 5 root 2 times smaller than that. That makes sense? Lots of I, plus 4, and then I need to make sure it's 5 root 2 times smaller than that, minus 3, and 5 root 2 times smaller than that. Okay? So that would be the unit vector. You can leave it however you want. I mean, you can see some cancellations down. I can rationalize the denominators. For example, I could leave this as root 2 over 2i plus 2 root 2 over 5j minus 3 root 2 over 10k, if you wanted to as well. That's the same thing. Either one is fine. Okay, any questions about that? That's the unit vector.
No question.
No questions? Good. Okay, so part B then, or part 2. Can you find the size of the acute angle between these two vectors? Okay, so in other words, I've got a vector u. Obviously this is in 3 dimensions, not 2. This is u, this is v. Can you find the size of the angle between those two vectors? So just remember, there is a formula, and it's in the formula sheet as well. I can find the cosine of that angle just simply by thinking about the dot products of the two vectors and dividing by the products of their magnitudes. Okay? So if I find each piece of the puzzle over here, let's do it in blue, because I quite fancy blue. U dot v, how do I find u dot v? That's one of the multiplication of two vectors. How do I find it? That's fine, that's fine. So u dot v simply just means multiply corresponding elements to each other and add them, okay? So 5, well there's no i's over here, so it'll be 5 times 0. Plus, and then I do the j's, so 4 by 2. Plus, and then negative 3 times negative 1. Okay, so 5 times 0 is 0. That's 8, that's 6, that's going to be 14. That's u dot v. Now if you remember when we looked at u dot v, we said that the u dot v actually tells us whether the angle is going to be acute or whether it's going to be obtuse, okay, or perpendicular of course. Now because that's positive, because cosine of theta is directly proportional to u dot v, or the sine of u dot v at least, then we can say that because this is positive, cosine of theta has also got to be positive, because both those things are positive. So therefore, because cosine of theta is positive, are you happy theta has to be acute? Okay? But let's check it out anyway. So magnitude of u we've already found, that was 5 root 2, we found that in the last question. Let's find the magnitude of v then. So that's going to be, okay, 2 squared plus negative 1 squared, that's square root of 5. Yeah? Does that make sense? Yeah or no? No. Okay, this one here. Yeah. Okay, so because I'm finding magnitude, just remember, I'll write the formula out on the right hand side. So magnitude of V will be the square root of that thing squared plus that thing squared, right? So 2 squared is 4 plus negative 1 squared. Maybe I just missed that out, right? So I just did that in my head just for the sake of space, right? Okay, so we got square root of 5 there. All right, so if I put all that into my calculator, or my formula at least, let's do cosine of theta is going to be equal to, well, u dot v is 14 divided by 5 root 2 times by root 5, okay? And I just need to take the cosine inverse of all of that to find what theta has got to be equal to. So hopefully, Chan, you are typing away already, which is great. Yeah.
Yeah, exactly. Vectors are here.
Vectors, I think, is the easier one. Yeah.
But it depends how much.
The advantage of, well, have we got an answer? 61.1. 61.1 degrees, okay. Thank you. All right, so there you go. Just remember as well that you have got an open book exam. Okay, so if you are struggling with integration and differentiation, there are solvers out there that can help you with regards to doing stuff.
Differentiation is also okay.
Good, good. Obviously the key is with these solvers, by the way, you know, the solvers are there to check whether you get the answer correct. Obviously you need to put the working down, not to, you know, just copy the answer, right, because you're not going to answer that. All right, fine, have we got another one? Okay, can we find the vector product of these two things? And that's the last part, and we'll probably finish off there. So, vector product, U cross B. Or U cross V, rather. Yes. So U cross V, we need to set up the determinant of a particular matrix. So determinant, remember, put the straight lines there, each side of the matrix, that means determinant. What goes across the top row of my matrix? Yep, the ijk. Because obviously we're expecting a vector out the other side, so we need to keep that ijk there. Okay, what goes across the middle row? So U cross V. Yes, it would. So it's in that order. So U first, then V. V cross U would obviously be the other way round, right? So U is 5, 4, negative 3. And then finally, the V along the bottom row would be 0, 2, negative 1. Does that make sense where I've got those numbers from? Yep. Okay, now I need to take the determinant of a 3 by 3 matrix. So you remember that the way we do this, it's a little bit of work, but it's not too bad. I'm going to take 3 copies of this matrix. So I'm going to take I, J, K, and then the 5, 4, negative 3, 0, 2, and negative 1. And I'm going to do that 3 times, okay? So, yeah, I'll do it down here, actually. So I'll just do it one more time. So I, J, K, 5, 4, negative 3, 0, 2, negative 1. Okay, so the way that this works, in fact, let me just do it again. I, J, K, 5, 4, negative 3, 0, 2, negative 1. Okay, so the way that the determinant works, you don't have to do this, you don't have to write it out in full, but you basically put plus, minus, plus first of all, okay? And then the idea is that you work your way through. So the first one, you start with the I. You need to start with the I first of all. Cross out that row, cross out that column, take the determinant of the remaining elements. Okay, so the remaining matrix is down here. So it's going to be I multiplied with 4 times negative 1 minus negative 3 times 2. That becomes plus 6. Make sense? Yeah. All right, good. And then the next one should be minus, because it's minus there. Okay, so next one I move across the j's. So I take the j, rule out that row and that column, take the determinant of the matrix which is left. So 5 times negative 1, so j times, 5 times negative 1 is negative 5, minus negative 3 times 0. Okay? And then plus, so we take the k next, rule out that row and that column, take the determinant of the elements which are left. So thus, it's going to become k multiplied by 5 times 2 minus 4 times 0. Does that make sense where I've got those numbers from? Yeah? Okay, good. So let's calculate this. 6 take away 4 is 2, so it's going to be 2i. Minus negative 5 take away 0 is negative 5, but it's going to become a negative negative, which is a plus 5j. Okay, and this one is going to become plus 10k. That there is the vector product, or the cross product of u cross v. Now just remind me, what is this vector that we've calculated? What does it give us? So this vector is incredibly useful.
It's like the one not in between, but
so if you think u and v, let's suppose that my u and v, so my u is going to be this forefinger, this v is going to be this finger here. So it exists in three-dimensional space somehow, right? This vector down here is the perpendicular one. Okay, so it's the perpendicular vector to u and v.
90 degrees.
Exactly, 90 degrees, perpendicular, orthogonal, all those words, right? So yeah, if you've got a vector and a vector meeting like this, the u cross v, the vector we just found, is always going to be perpendicular to it. All right. So yeah, if it says in the question, find the perpendicular vector to u and v, cross product. Okay, that's another way of saying the same thing. Make sense?
We need to know.
Yes.